So, if you are looking for an intriguing solution to help you manage data in memory, it's worthwhile considering QuickSelect for Db2 from Logon Software. QuickSelect offers a novel approach by caching frequently requested query results in memory, not full tables, not table pages, but query results. It essentially offers a unique solution to an age-old problem. With QuickSelect, you can save I/O, CPU, and elapsed time, and that should improve overall response times. It can enable you to get more throughput from your current system and improve your user and customer experiences. So what does QuickSelect do? As I mentioned, it caches query results, not entire tables. The results of frequently run static SQL queries are kept in memory, where those results can be accessed quickly and efficiently the next time they're needed. When you have QuickSelect installed, it will service your frequently run queries while you let Db2 service all of your other requests. Keep in mind that QuickSelect returns the same exact result sets that Db2 would. However, it returns the data from its cache, saving that expensive round trip to Db2 to get the data. This can significantly reduce elapsed time and improve response times, saving both CPU and I/O. Of course, this begs the question, which queries should be cached? And generally speaking, you should cache frequently executed queries against data that's not rapidly changing. QuickSelect comes with a survey mode that can automatically find SQL queries that are most suitable for caching. The next question you probably have is, what happens when data changes? Well, QuickSelect has built-in table update sensitivity. It invalidates cached result sets when underlying Db2 table data changes. When the cache is invalidated, the next time that query runs, it will go to Db2 for the data. So you always get only the current data. And the impact to your existing Db2 system and applications is minimal. QuickSelect is plug and play, and that means it's transparent to your existing environment. It can be turned on and off without impacting your applications. There are no program changes required to implement QuickSelect, and that includes no JCL changes for your batch jobs. QuickSelect can be implemented very quickly, and QuickSelect fully supports Db2 data sharing. So let's dig a little deeper and see how QuickSelect works. Here we see an application sending a query to Db2. A lot of work internal to Db2 is required to retrieve the data and return it to the requesting program. This involves things like access path formulation, checking Db2 buffers, sorting data, transforming data, and so on. But what happens if we add in QuickSelect? Well, QuickSelect intercepts the call and checks to see if the results are cached. If the results are in the cache, QuickSelect just returns that data from its cache, as shown here by the green arrows. There's no need to go through all the machinations inside of Db2 on the right-hand side here on this diagram. So QuickSelect is installed between the application and Db2. The first time the query is issued, QuickSelect passes the query to Db2, where the result is created and given back to QuickSelect. So QuickSelect stores the query and its results in the QuickSelect cache. When the same identical query arrives again, QuickSelect answers it with the content of the cache instead of having to go to Db2. So let's track QuickSelect in motion through its various operations. And we'll start at the very beginning. Here we have a query issued from a program. Assuming it has not been run before or that QuickSelect is newly installed, the query must first go to Db2 using the standard interface. This follows all of the standard Db2 rules and operations, including security and data access. So QuickSelect is not yet used. Okay, So let's look at the next consideration, which is whether the SQL is eligible for QuickSelect caching. QuickSelect is read-only and for static SQL only. So inserts, updates, and deletes are not eligible, nor is dynamic SQL. When the SQL is not eligible, it passes right to Db2 for standard processing, as if QuickSelect is not even there. Next, let's take a look at some other qualifying considerations for QuickSelect. Assuming we pass the eligibility check, meaning it's static SQL select statement, the data must already be in the cache for QuickSelect to be able to return the data. If the data is not already in the cache, the query is passed to Db2 to run. Furthermore, a repeatability threshold must be met. We want to cache query results for recurring queries, not for every query that's run. Okay, we're going to run the same query again. It is eligible, but the data has not yet been cached by QuickSelect. This time through, assume it passes the repeat threshold. The query is sent to Db2 to execute, and the query results are stored in the QuickSelect cache. Okay, so now we're set up to benefit from QuickSelect. The query is eligible. The data is already in the QuickSelect cache. This means that the query can be satisfied directly from the QuickSelect cache without processing it in Db2. I know it seemed like a lot of slides to get to this point, but consider a query that runs hundreds or thousands of times in your system. Only a few of these will need to be sent to Db2 to process, with the vast majority being satisfied by QuickSelect from its cache in memory, as shown here. Now, at this point, a common question that a DBA may have is, isn't Db2 quick enough already? And yes, Db2 can be quick, but not as quick as simply accessing the data in memory. Consider a typical access from an online transaction. If the request is supported by an index, Db2 can get to the right data page in a huge table. But even so, if there are multiple index levels, it can require multiple IOs to get to that page. For example, here we see a direct index lookup requiring up to 4 IOs, 3 in the index, with 1 for the root page, 1 for a non-leaf page, and 1 for the leaf page, and 1 for additional IO for the data page in the table space. Okay, so what type of queries are ideal for QuickSelect caching? Let's look at some sample data here. The green threads are all processed by Db2 very quickly. You can see here that the topmost queries are all sub-second response time. Then there are the threads that consume a lot of CPU. These are your elephants. And a lot of times organizations or DBA teams spend a lot of time trying to tune these queries. Often these are complex analytical queries, and they can be candidates for running on IDAA, the IBM Db2 Analytics Accelerator. But if you look at the number of threads indicating the number of times a query is being run, you can see that the amount of CPU being consumed by the simple but repetitive queries is significant. For example, the thread running over 10 million times is consuming over 4 hours of CPU in aggregate. So it's these mosquito swarms, not the elephants, that QuickSelect targets and optimizes. So the goal is for QuickSelect to improve the performance of repetitive queries. It can achieve this because fewer CPU cycles are needed to answer a query. Think of all the operations involved in satisfying that SQL query. But with QuickSelect, there's no locking required, involves no disk I/O, less CPU needed to simply read the data because it's in memory. You don't need to utilize the full power of a DBMS like Db2 to get to the data when we already know we've run it once and the data's all in memory. Now, there are many benefits of using QuickSelect to optimize the performance of repetitive queries. Yes, it's a vendor solution, but there's no lock-in because all you need to do to remove the product is simply deinstall it. No program changes, no JCL changes, no Db2 changes are needed in order to use QuickSelect. QuickSelect uses above-the-bar memory, and you should have plenty of that memory. And it can pinpoint just the queries you want to optimize using its survey. And the bottom line is that QuickSelect returns the same data that Db2 would, only faster from its in-memory cache. Okay, let's look at some QuickSelect customer examples. Here are two short customer success stories for QuickSelect. First is a large commercial bank running Db2 and CICS. They had a buffer pool dedicated per Db2 table. With QuickSelect, their production load ran 24% faster in CICS, with 16% less CPU on the machines. Secondly, we have another large European commercial bank, this one running Db2 at IMSTM. After installing QuickSelect in production, they were able to turn off one of their CPUs by implementing only low-hanging fruit. This is a significant environment where they run over 10 billion SQL statements in a typical 12-hour window. Here we see some performance statistics for a targeted plan. This one's named SX0630, and it's shown here before QuickSelect. This report is sorted by package CPU usage. The plan overall consumes 107 ms. The highest consuming package, BU021ADDI, uses 70 ms. Here we see that same report for plan SX0630 and its packages, but this time after we've installed QuickSelect. Again, it's sorted by package CPU usage. The plan overall now uses only 7 ms. Remember, it used 107 before. The highest CPU consuming package, BU021ADDI, no longer even shows up on the report because its queries were answered by QuickSelect. Here's a little more detail with the two graphs showing the effect of adding QuickSelect. In this case, QuickSelect was activated at 6 a.m. and deactivated at 6 p.m. And you can see the impact it had by reviewing the two graphs here. On the left, we see that the calls to the plan were highest during that 6 to 6 time frame. But turning our attention to the graph on the right, we see that the calls for the previously high-consuming package are significantly reduced during the time frame that QuickSelect is active. This is because it's accessing the data in memory from the QuickSelect cache. To drive home the point here, we are showing some examples from Db2 SMF records. Examining a 6-month period from May to October, where there was no reduction in workload, we see an 18% reduction in Class 2 CPU time and a reduction in reads by about 50%. So QuickSelect has made a significant impact in this environment. So summing things up, with QuickSelect, you can automate caching Db2 query result sets in memory. By caching frequently requested result sets in memory, you can potentially achieve improved online performance and shorter batch windows. Furthermore, QuickSelect can help you to reduce CPU, I/O, and Db2 resource usage and lower your overall CPU consumption. This can help to reduce your MLC software charges and thereby may help you to be able to reduce costs in your mainframe environment. So think about how QuickSelect for Db2 can improve the performance and cost of your Db2 for ZOS environment. That brings us to the end of the session. You can reach me at the above email address and website, and you can reach Logon for more information about QuickSelect at the contact information that we show here. Thank you for watching, and good luck as you manage and optimize your Db2 environment.